Hi guys, this is Dan Bentley from Section D, and as we prepare for our second assessment, I'm just going to look at some highlights from week 6, 7, and 8. So this video will talk about it, just a quick highlight from week 6. Nothing too complicated. I just want to look at graphs of rational functions and their reciprocals. So you've done some investigations on this, so it shouldn't be too new, but let's just, as a bit of a recap, here we go. So if I have a function, and I've just have a quadratic over a quadratic, so if I want to graph this by hand, so the first thing I look at is I want to think about the zeros, okay, of the function, where this graph is actually going to go through the x-axes, the x-intercepts. So this is where I set the numerator equal to 0. So just doing the math quickly, on the numerator equal to 0, I get negative 2 and 2. Next thing I want to think about is the vertical asymptotes. So this is where this function is going to be undefined. So this is where the denominator equals 0. So working with a denominator equal to 0, this is a quadratic that's pretty easily factorable. And so I factor that down, and here I get my two vertical asymptotes. So before I run over to my graph and start putting these on, I'm also going to think about my horizontal asymptote. And so our horizontal asymptote is, we look at the leading coefficient, the leading degree of your, both of your functions on your numerator and denominator. And in this particular case, they are the same. So in this case, since they're the same, they're both 2, we look at their coefficients. Okay, so we look at they're both 2, so we're going to look at their coefficients, which in this case is 3 and 1. So it's simply just 3 over 1. Look at their coefficients, and it's 3 over 1. Okay, so now I've got a good amount of data that I can run over to my graph, and I can put this on. I've already got my x-intercepts there. I've put in these asymptotes here. And now it's just a matter of kind of plotting some points. One more thing I can do is I can get that y-intercept. To get the y-intercept, I just need to find what f at 0 is. So quick work for f at 0 gives me 0, 3. And then I can just start sketching my graph through. And I did that pretty quickly, but basically you could just throw in a few points. You could throw in 1, you could, well, let's say not 1 in this case, but you could throw in 3, you could throw in something on the negative side, and you'll generally get a feel for how this graph swoops through this. So try a couple points, but you'll generally get the feel for that. Now, one thing to note, that y equals 3 is a horizontal asymptote, but you're saying, well, wait a minute, I just went through it. I didn't think I could come crashing through an asymptote. But the asymptote is, talk about our end behavior of our functions. Okay, so as this function goes off to negative infinity and positive infinity, they approach 3 from the negative side and the positive side. It is possible, more in the middle of our function, that we can actually pass through an asymptote. Okay. So just kind of moving along here, there's a better picture of it with not my squiggly handwriting. Let's say we want to do the reciprocal of that. And if you remember, a reciprocal is 1 over the function. And in the case of fractions, this simple thing is to just flip the fraction. The numerator becomes a denominator, the denominator becomes a numerator. So I've actually already done all of the math. So what I can do is I'm basically just looking at everything a little bit differently here. For my zeros, my numerator equals 0, so you see my work here. So these are my x-intercepts, but this is what was my horizontal asymptotes, if you remember from a few screens ago. Okay, so I'd kind of already done that work. That was the factoring that I'd done earlier, but now instead of vertical asymptotes, these are now x-intercepts. And the same is true, and I look at this denominator, equal to 0, and you'll recognize these numbers, and these numbers were my x-intercepts. They are now going to be my vertical asymptotes. And then one quick other thing, let's look at that horizontal asymptote. And as I mentioned before, we'll look at those leading coefficients because both of the highest degree of the numerator and denominator are both 2. And this is 1 over 3. And that shouldn't surprise us because the horizontal asymptote was 3 before, and now we're talking about the reciprocal, so that's 1 over 3. Okay, so I can quickly, here's my other graph. Let's just start plotting some of those points that I just found, drawing in my asymptotes, and then I can also just sort of work with checking for, actually I usually start with my y-intercept, and then I draw through my y-intercept. And I've got a lot going on in this graph here because I've got both asymptotes and both functions. But what I always suggest is, there's a better picture of it, what I always suggest is just look at any one point that you have. Look at any one point and see that they are the reciprocals of each other. So if I, for instance, I look at my red graph here, right, my f at x, and I see the point 3 right there, and on my blue graph, or my reciprocal, is it 1/3? Yeah, it seems to be. Even maybe look over here, I have, let's see, at -8, looks like I'm up at about 5 right there, -8, 5. So on my reciprocal, is it -8 1/5? Yeah, it looks pretty close to 1/5 right there, because it's below my 1/3 asymptote. Okay, guys, I've kind of talked enough here, but that's just the basics of your graphing a rational function, and also a quick look at its reciprocal. Okay, stay tuned for the next video.